Hi, Assalamualaikum warahmatullahi ta'ala wabarakatuh. This is the lesson 1, still reading lesson 1, but another 2 questions on lesson 1. We just continue on the previous session. Let me read through question 1. We have a 2 question for this lesson, question 1 and question 2. For the question 1 is just like you see in the screen. Question 1a, answer the following question. Right, okay. Give two main differences between vector and scalar quantities. Give example for each. Give example for each. And the number 2 here, question 1, A2 here is A2 and this is A1. Let me change the color of the ink first. Let me go with the red. Question 1A2 briefly explain 3 important steps required in solving equilibrium particle problem for force in plane. Okay, 3 steps solving equilibrium particle problem for forces in plane. Okay, for example, for the solution of number 1a, vectors and quantity. This is the favorite question for static. What is different between vector and scalar? So vectors has a magnitude and direction, right? While the scalars has the direction only. Okay, the vectors usually has a this is one because the question asks you to give two differences. So this is one. Another one is vectors has 3 dimensions, while scalar has only 1 direction or dimension. Okay, got it? So you harus know kan, sepatutnya I wrote like this in the table, because if the question asks you to find the differences, it is the better way to use the table so you can differentiate easily. So this is vectors, this is scalar, magnitude and direction. Well, this one only has a direction. That's number 1. Number 2, 2 or more, 2 or 3 dimension. Dia tak semestinya 3 dimension. It can be 2 dimension also. For scalar, only 1 dimension. Okay, scalar only 1 dimension. That's it. You can have 2 marks on there. 2 marks. And question 1a, 2 briefly explain. Briefly, you have to highlight that. Briefly, maksudnya ringkasan saja, explain secara ringkasan saja, tak perlu panjang lebar sampai setengah muka. 3 important steps required in solving equilibrium particle problem for forces in plane. Okay, 3 steps. First one, free body diagram, FBD. The second one is force triangle. triangle. What is force triangle? Free body diagram tahu kan? Kalau ni ialah you punya particle. So you lukis lah dia punya free body diagram dia. Apa yang acting on that particle. Kalau force triangle, so you combine all those forces to make a triangle. Example, this example here, you make it di sini, oh my goodness, di sini. Sepertinya macam tu lah, force triangle. And the third one is we still on the step. Okay, and the third one is this song summation of fy equal to 0 and the summation of fz equal to 0. This is the 3-step if you want to solve equilibrium particle equation problem. Equilibrium particle problem. Solving equilibrium particle problem, you need to sketch FBD and then force triangle, and the last one is to solve or to have a 3 important equation of this summation of fx in x direction equal to 0, summation of fy in y direction equal to 0, and summation of fz in z direction equal to 0. So that is the 3-step. We're done with the part 1 of question 1 and part 2 of question 2, which is question 1b. This is the part that you have to solve using a calculation. A lamp with the weight of apparatus Newton, 800 Newton. This is your lamp. This is your lamp here. Is suspended at point A and supported by 3 cable. Suspended by 3 cable. AB, where is AB? This is AB. AC, this is AC, and this is the AD. Okay, if the system in equilibrium, which means the system is static, tak bergerak lah. Answer the following questions. Okay. 1. Draw free body diagram of point A. Ini masalah particle equilibrium tau. Sebab A ni as a particle ni satu point lah. So kalau awak lihat balik apa yang awak tulis kat atas, first awak kena how to solve that particular equation. First, you need to have FBD. Second, you need to have a force triangle, and the third, you have to solve this using static equilibrium of equation. Summation of fx equal to 0, summation of fy equal to 0, summation of fz equal to 0. So same goes with here. You need to draw FBD first. So FBD of point A. This is the FBD of point A. That direction with some angles. That direction in Z direction because your Y X and Z is that direction. This is your axis. So this AC is pointed in the Z direction. AD pointed in the Y direction, Z direction, and X direction because it is like that. Okay, you can see it is not in the plane of X and Z, and also it's not the plane on X and Y, so it is in the middle there. So this is the force that acting on the point A in X direction. So this is AB. Let me put as F as the force or reaction, and this is FAD, and this is FAC. Don't forget with the weight there, with 800 Newton. So this is your FBD. Okay, this is your FBD. FBD is free from any attachment. So you just need to sketch or to draw the reaction or the forces that acting on the point A. That's we call it as free body diagram. Number 2, calculate the tension in cable AB, AC, and AD. Because of tension here, but we are using F, so supposedly tension is T, capital T. So doesn't matter. It's just a sign of force that we introduce in the solution, but no problem. So the question asks you to find the tension of cable AB, AC, and AD. So in your understanding, you must know that your FBD, the tension there is used it's used the alphabet F in your free body diagram. Okay, don't get confused with that. So how to find that? AB, AC, and AD. You have free body diagram, and then you need to have a force triangle, right? Force triangle, because this is the step that you are mentioned before. You need to have a force triangle. If you can see here, we need to find the angle of, sorry, let me make it properly, the angle between, let's say this is O, origin. So we need to find the angle of D, the angle of DAO, which means the angle it is in the middle of these three alphabet. Okay, DAO. If you put DOA, the angle there, which means we want to know the angle at the middle. So it is 90 degree. Okay, you must know the sequence of that alphabet if you want to know the angle. Kalau you tulis macam DAO, which means we want to know the angle at the A between D and O. If you want to know the angle between if you want to know the angle of O, so you must write that in this direction, D, and after that O, and after that A. So we know, generally we know that you want to know the angle at the middle, the middle alphabet. Okay, so in this case, you want to know DAO here, DAO. And also you need to find the angle of here, which is let me put it as a B apostrophe here, because this is B and B here, it is in the line. Okay, so we need to find this angle. Okay, this angle. So what that angle is, O A B apostrophe. Okay, that angle first. You have to solve that angle first before you can use any force, or before you can solve the force of that or the tension of that AB, AC, and AD. You need to find that angle first. So in order to find that angle, here, you need to find, you need to know the trigonometry, simple trigonometry, sine, adjacent, opposite, divide by hypotenuse, cos, adjacent, divide by hypotenuse, and the tangent is equal to opposite divided by adjacent. This theta here, theta here, theta here. Okay. Let's say you want to find angle DOA, DOA here. Oh, so sorry, not DOA, DAO, sorry, DAO. So you need to use what kind of trigonometry here? So if you sketch the fourth triangle, not fourth triangle, the triangle itself, the theta here, in order to know the theta here, you need to know either the length of AD or the length of OA, right? Because DO you have it already, 4 meter. If you have dimension of AO, you can use tangent, because this is opposite of this angle. Opposite here is DO, and the adjacent is AO if you have AO. But we don't have that. You need to find you need to use this triangle first, because we know that from x-axis to B, line B is 2 meter, while between z-axis and the C line here is 4 meter. Okay, so you can find the angle. This is 2, this is 4. You can find the hypotenuse of that angle, and also you can find the angle of OAB, right? Okay, how to find that AOB first? AOB first, you need to use a tangent. You need to tangent AOB. Let's scrap that before. Angle OAB, which is there. Let me change the color, not red anymore. Which is there. Oh, this pun tak bagus. Blue. Okay. So saya dapat angle there 2, 4. We dapat angle here. So you need to use tangent. Tangent theta equal to 2 divided by 4. Then tangent inverse equal to 1/2. You press calculator, you dapat. Press calculator, you dapat berapa? .56 degree. If you want to find the distance between O to A, this is B prime, O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to find the angle of OA. This is B prime. O to A. How to find that O to A? You need to fi I hope that you know how to find that angle or the distance. OA equal to, this is completely mathematics, okay? 2 squared plus 4 squared equal to squared plus 4 squared square root 4.47 m, okay, meter. We not find any force yet. We are only deal with the meter and the angle first. If you got the angle and the distance, then you can solve for the force. Okay, so you got the OA, the distance of OA, and then you can find the angle of DAO, the angle of DAO. Green, let me use green, angle of DAO. This is your A, this angle, this is your D, this is your O. So how to find that? You have 4 meter here, and you have the angle here, not the angle, the length of OA, 4.47. So you are using tangent again, tangent theta equal to 4 divided by 4.47. Scroll little bit. So tangent theta equal to tangent inverse 4.47, which is 4 divided by answer, inverse tangent, answer 41 degree, 41.81 degree. Alright, so done. You are finished with the angle and the dimension or the length that required to you to solve for those tension AB, AC, and AD. So and then you solve for summation of fx and summation of fy and summation of fz. Okay, summation of fx equal to 0. Look at your problem here. Where's in x direction? Is there any force in x direction? This is your x. Is there any force in x direction? Yes. B and AO here. Sorry, AD here. There is force in that direction. Force AB, force AB, we are only taking force in x direction, not any z or y direction. We only take x direction. So force AB, is there any force down there? Yes, you have it. So you need to find the force that acting in that way, that component of A and D, the component of force A and D. Okay, so you need to find the component of this. Okay, how to make this as the component of B direction or X direction? You need to use another trigonometry. me small it because I have very difficulty in scrolling and scrolling. So negative, why is that negative? Because it is in opposite direction of your x-axis. Okay, negative. First of all, you need to find this direction x. So this is the same angle as there. So 800 ni boleh ditransfer pergi ke sini. It is still positive, no problem. So you need to find this OA. Sorry, OD. Sorry, AD. So you have the angle. We have the angle. Angle green there is similar to here. So you have 800 and the hypotenuse is empty. 400. 400 sine theta, is theta here, equal to 800 divided by AO. This theta is equal to 41. So AO equal to 800 sine 41.1. So you got the AO. After you got the AO, then you need to transfer it twice. Okay, no problem. So you just write AO here. Then you transfer it to not AO, it is AD, sorry, it is AD. Here AD and this is AD because the point over there is D, not O. So you got AD here, then you need to transfer to AO. How to find the AO? AD cos this angle 41.81. So this AO become AD. Sorry, this one AD. And you another cos for this angle, cos 26.56. You got the force that this angle on this angle, okay, equal to 0. So you got FAB equal to AD cos 41.81 cos 26.56. Okay, AD you can get from here 800 divided by sin 41. So you can find the FAB. Because the AD, post AD, you immediately can find it from here. This is post AD, this is post AD, this is post AD, this is post AD. So FAB from there. So let me press the calculator for you. Post AD. Post AD. If you press calculator, you will get this is negative. Why it is negative? Because it is pointing downward, opposite opposite to your y direction. So it is negative. So if you press calculator, you will get minus 1200 Newton. Yes, 1200 Newton. While your FAB, just complete this equation. Minus 1200 Newton cos 41.81 times cos 26.56. So your FAB, it is equal to FAB, what is your FAB? Minus 800 Newton. So you got minus on that direction. So your FAB is actually positive. So it is positive there. It is just a matter of direction, the negative one. So you got the FAB 800 Newton. Then you can solve for FAC. FAC there. This is your FAC. To solving FAC, you just complete this equation. Not this equation, this triangle. You know this angle here is you have 800 Newton minus 800 Newton with this angle 26.56, so you can get the angle there. Okay, angle in the opposite direction. So just complete that, you get force from that. So or you can use summation of Fy. Summation of Fy equal to 0. FAC in the positive, so negative 1 is there, this negative BO, negative BO. So which is equal to, let me scan through, OA, B prime, A, then those angle. So if you get this minus 800 on the, this is 90 degree. So you want to know this force. So you have to use sine, because this is the hypotenuse. Okay. Sine sine 26.5 equal to B prime O divided by minus 800. So minus 800 equal to sine 26.5 tentang. No. You need to use tangent, not sine. Need to use tangent. Okay, that's why I confused it. Tangent. Okay. Minus 800 tangent minus 800 tangent 26.5 equal equal to 0. Then you can find the FAC. Which is equal to 100 Newton. You can see that how it is if you look closely how I'm solve this equation or this problem. The problem is actually easy, but it will be a tricky one. As long as you do a lot of exercises, you can solve or you can calm down the tricky part of this question. Okay, if I as a lecturer here have a difficulty in the tricky one of that question, so if you not make if you not make any exercise according to this problem, this lesson, you must have a difficulty, okay, to solve this particular problem. Again, I remind you, this is just a tutorial for you to solve with a guideline. Okay, you have to solve it by yourself and understand by yourself. Okay, and if you do a lot of exercise, you more understand of what you don't understand. If you understand of what you don't understand, so you can countermeasure any problem you face. You will know how to solve it in a practical way. Okay, this is the practical way. Okay, and there is another way, another way to solve this problem, and this is only the one way. If you try to use another angle here from this angle, you can also define this angle to this angle. Instead of using this angle, you can use this angle there, using your own way of solving. So you can find or you can earn the same answer there. Okay, this is just one path of the way to solve. There's a lot of another path which is also correct way. So what most important is free body diagram. You have a correct free body diagram. You know very well how to translate the force and make it as a triangle and solve it with the summation of fx, summation of fy, and summation of fz equal to 0 here. Okay, if you know how to use these three perfectly, you don't have to worry what kind of problem will you face in the final exam later. Okay, let me remind you again, please do a lot of exercises on this part. We come to the question number 2 with the aid of simple diagram. I read there, question 2a, with the aid of simple diagram. Briefly explain the principle of transmissibility. Okay, the principle of transmissibility. For example, you have a block here. Let me sketch the center line of that block. And there is a force acting on that center line. Exactly the principle of transmissibility here, you can transfer this force into this. Okay, for example, this is equal to that direction of force. the same. Originally, the force is acting on the A side, but you can transfer it as long as it is lie on the same line. Okay, you can transfer it to the B side. Same goes if you have doesn't matter which is in the center or not the center of that block. If you have a force that acting on the lower side of the block, which is the force is acting there, it is equal to the force that you translate to another side or B side there, as long as it is in one line. For example, again, this is the principle of transmissibility. For example, again, you have a L block. You have a L block. You have a L block here. You have a force in this direction. Okay, in this direction. So you want to transfer those force to in line to that line here. So the force becoming like this. This is your block. So this is your line that I copied from there. This is your force. That is because of transmissibility. Okay, principle of transmissibility. As long it is the force is lie on the one line, okay, not curving line. Kalau you punya line curve, ada force kat sini, dia taklah acting kat sini, salah. Dia mesti one line yang lurus. Okay, kalau you punya shape bentuk dia begini, surface dia, so it may leave like that also. You cannot transfer the force like if the force is the shape of the force is like this, and you want to transfer that force into the shape of like this. This is very wrong. Not, you cannot transfer that. Okay, because the shape itself is different. The shape where the force is acting on. Okay, the shape where is the force is acting on. Tak boleh, ni tak boleh sama. Sebab ini one line and this is not one line. This is because the shape of the surface itself represent the wrong line. Okay, that's the principle of transmissibility. And number 2, question 2A2, the concept of right hand rule determination of moment of a force, which is will resulting you a positive sign and negative sign of moment. For example, you have a problem or a question like this. This is point A, this is point B, and this is your angle or your force there, force F Fy there. Okay, so from the right hand rule determination of moment, so your Fy or your moment at point A here, moment at point A should be negative because you are using the right hand rule. Okay, if you use the right hand rule, the force is on your fingers there, and the moment is true. The moment represent the thumb, through the paper. So it is rotate counterclockwise. So if the rotation is counterclockwise, we can say that the moment is negative. Okay. So if you find the moment of Fy at point B, so the moment of Fy at point B, so it is positive because it is pointing upward, not upward, outward, pointing outward of that paper. So that's the rule of moment, right hand rule moment. Okay. I hope that you understand these two principles, principle transmissibility and the concept of right hand rule. And question 2b, figure 2b shows down there, figure 2b shows a level of ABC, which is hinged at B and is attached to a cable, to a control cable C. The lever is subjected to 500 Newton vertical force at A. 1. Draw a free body diagram of member ABC. Label all important points and forces. 2. Determine the tension in cable CD and direction at point B. And the last one is identify the force member and justify it. Okay, identify the two force member and justify it. First one, draw free body diagram ABC. Label tu free body diagram dia FBD. This is point A, this is point B, and this is point C. It is there. Direction force of TCD, the cable TCD, and the direction force that acting on the hinge. We have two F, sorry, not F. I'm using BX or BY because this is my X and this is my Y. This is my Y, this is my X. So this is BY and another one is here, BX. So duration at point A is only 500 Newton there. 500 Newton. Okay. Draw a free body diagram of member ABC label all important point and forces. Is there any weight of that label? No, no weight. Okay. So this is your FPD. And number 2, determine the tension of in cable CD and direction of point B. Tension CD and direction at point B di sini, BX, BY, and TCD. So to solve this, you have to start with summation of Fx equal to 0. List down all the possible forces at X direction. So Bx from there for this one, and plus TCD, tension CD, which is in X direction. We know that because this is the resultant force of tension CD. So we can split this TCD in X direction. So what is the direction of that TCD? So you need to find this angle, right? Then you can find this force acting on x direction. So those theta equal to tangent inverse 24 opposite divided by 10. So your tangent, your theta is 67.4 degree. Is the cos 67.4 equal to 0. So your bx so this is the equation of fx equal to 0. So this is equation for summation fy equal to 0. In y direction, there is this direction 500 Newton minus 500 Newton, and also this direction minus TCD. Why it is minus? Because it is opposite to y direction, because my axis is upward is positive for y direction, so the arrow here is pointing downward, so it is negative. So that's why I'm putting negative TCD there. So minus TCD sine sine 67.4 and minus positive bx equal to 0, because this not bx, by, 500 Newton positive by, because we are finding any force that acting on y direction here. So minus 500 Newton positive by, and this component of tension CD in y direction. So this is all that. And the last one is the moment, summation of moment at point B. Summation of moment at point B equal to 0. So summation of moment at point B equal to 0, where clockwise is positive. No, counterclockwise is positive. Which is 500. This 500. We need to find the angle of or the direction or the distance between A and B in X direction. Okay, A and B. So you need to find that. Because times 20 minus 2 cos 20. Cos 20 come from that, because this is also 20 degrees Celsius. Sorry, not Celsius, degree. And the moment point acting on point B also here, TCD in X direction, and also TCD in Y direction. So it is minus TCD for this one Okay, TCD for this one, which is, just write it back, minus TCD sine 67.4 times the distance between here to here. Okay, distance. So 30 degree, 30 centimeter, cos 20. So time 30 centimeter cos 20. Right? It's not finished yet. We have this one, TCD in x direction. Another minus there. It is continue, okay? Minus TCD cos 67.4. That is the force. Represent this force, and we need to find this distance, which is 30 centimeter sine 20. Okay, 30 centimeter sine 20 equal to 0. If you solve this equation, long equation there, you can find the equation becoming like this: 93, 96 minus 0.26 TCD minus 0.04 TCD equal to 0. This TCD and TCD ni, TCD ni and TCD ni, you can solve it, becoming 93.96, 0.3 TCD equal to 0. So your TCD is 93.96 divided by 0.3. So you got 313.7 Newton. Once you get TCD, can you find the Bx and By? Yes. How? Just replace this Bx, the first equation there. So Bx equal to minus TCD cos 67.4. So minus 313.7 cos 67.4. So you got what yours Bx. What yours Bx? Oh, I haven't calculated. You can calculate it for me, no problem. After that, you find the Bx, and you need to find the By also by using this formula, not this formula, this equation, because TCD you have it and you don't have a By. You rearrange it back and make it By as the head of function, then you can find, let me write it for you, the equation: 500 plus TCD sine 67.4. The TCD itself is 500 plus 313.7 sine 67.4. So you can get the answer there for Bx and By. Let me see through the answer or the question there. So we already find the answer for question 2B1 and 2B2 here. So we left behind identify the two force member and justify it. The two force member is actually there. You can see in tension C and D. So it is actually, you can solve it simply by knowing how to find the force reaction at point D here, which is equal to so this is CD, right? So if you want to find the angle, or sorry, the component force at this D, which is actually similar to what happened in C. So this is your answer for question number 2B 2B3 here, 2B3 Roman. Okay, got 2 marks there. Hope it answer the question there. That's it for the first lesson. Another 2 question for this station. I hope that you do a lot of exercises for the lesson 1. If you not do any exercise, you will texting you, not texting me, it's texting you, because you cannot do any analysis on this problem. Okay, if you find difficulty to solve this problem, go back, find a problem with similar lesson to this, and you can ask me through WhatsApp or email or whatever you want to do. Okay, I will reply to you as soon as very possible. Okay, that's it, lesson for today. uh, thank you again. Assalamualaikum.